Welcome to School of Civil Engineering. In our previous video, I have shown you that how we'll analyze and design a beam and column, and in this video I will show you that how we'll analyze and design beam and column together with a structure. So let's start. And if you're new here, you can watch the previous video that I have created in that playlist. The link is given in description. Also, they have many video about EDAPs and also another software. You can watch that. The link are also given in description. First of all, I'll open STAAD Pro and then I'll go here, new project, space, then I'll give name beam column design, BCD. Okay, no problem. Then length unit, foot, and force unit, kilopound. Next, add beam. Okay, finish, done. Then I will use that plane. To draw my beam column. Suppose first of all we'll click 0 point, and suppose we have a 8 feet height column here. We'll press here 8 feet and 10 feet long beam. So we'll go here, it's 10 feet, and again we'll go down here, done. Then we'll go here, snap node or beam. So you can see that we have found her. That's the beam and that is the column. So we'll go here, view from +Z, and here is our beam column. Now I'll press node cursor and I'll go here for select the 2 node, and I will assign here, create, fixed, assign, close. We have assigned fixed support on here. After that, we have to define materials property, material page. We'll consider that a column in rectangle, that column in circular, and that beam in rectangle. So define circular, 1 feet, add rectangle here, 1 feet and 1 feet, add, and again I'll go here for rectangle, or you can select trapezoidal as your requirement, and you can add according to your requirement, but I am going here rectangle for beam. It's suppose it's also 1 feet and 1 feet, add, close that. So from here, first of all I will select circular and click here, use cursor to assign, then use cursor. Then again I'll go here, I'll select that 12 into 12 and I will click here, and again I will go here and I will click here. So we have assigned our all materials, close that. If we see in 3D mode, you can see that these are beam column and that is circular. Okay, done, close that. After that we'll go here, load case, default, details, then add. First of all we'll just only do it for dead load. Okay, add, close, then click on dead load, add. From here we need self weight. From self weight we have to select self weight in y -1, factor -1, add, and I will go here member load. For member load I'll select 10 keep, consider 20 keep, and I will not give any data here because I will assign that 20 keep load on full beam. So global y, and it should be minus 20, add, close. Okay, done. Then self weight, select beam cursor and select wall. After that self weight and assign to selected beam, assign yes. After that unit weight, uniform distributed load 20 keep, I will assign that in beam. So beam cursor and then select beam and select beam cursor, select that and assign to selected beam, assign yes. So click here, loads, you can see that it's here. So we have assign our load, we have assign our materials property, we have also assign our we have also assign our support. Now we'll go for analysis, command analysis, perform analysis. Okay, again we'll go here, run analysis, save, then run analysis. From here you can see that they have no error, no warning and no node. Then go to post processing mode, done. Okay, after that if we press Ctrl and click on here deflection, click Ctrl and scroll your mouse, then you will see the deflection of our model. So if you notice one thing, that suppose that this is the initial mode of our structure, and when we are scrolling, first of all beam are deflecting, and after that our rectangle column are here like default, but it's starting deflecting. So it's also deflect many, but our rectangle column deflect very low, and if we increase the deflection we can see that column deflect very much. That's why rectangle column are more suitable than circular column. Here you can see that it deflects very much. So after that if we go here support Fi, press Ctrl and scroll button, you can see that the SFD, and close that and go for BMD. You can see that this is the BMD, and press here to stop deflection. Here is the BMD. Okay, done. So that's why we can analyze a frame with a beam and with a, and also we can found our reaction. So from here you can press here, select text, and you can move that is. So for X direction it's showing 19 keeps, and for Y direction it's showing that keep, and here for X direction it's showing that load, and for Y direction it's showing 100.36 for keep. In that point and that point there have a load variation because our circular column self weight are less than our rectangular column. So this is the way to find out every value, and from here we can see the axial force also. Press Ctrl and scroll your mouse. This is the axial force of our column. Press on it, and also we can see the animation. Press here, animation, deflection, apply. We can see that this is the deflection of our model. So we can also reduce the deflection rate, suppose 5, apply. You can see that it deflecting very low. We can also deflect that, supply is deflecting in very low rate. We can also increase the deflection rate and it deflecting very high. So close that, and no animation. Okay, after that we have to design our beam and also that beam and also that two types of column. So in our next video I'll show you that how we'll design our beam and also that two types of column. So stay well, stay connected till next video. Thank you very much.